In the beginning, the universe wrote its story in light. Trillions of stars, each born, living and dying in its own mysterious rhythm. And across 8 stories, we uncover how stars are created, how they live, how they end, and the strange, impossible ways they sometimes break the rules. This is the Star Series, a journey into the quiet, violent, and unpredictable heart of the cosmos. Ever wondered what the universe is mostly made of? Stars. And there are a ridiculous number of them. Astronomers estimate up to 1 septillion stars out there. That's a 1 with 24 zeros. And the Milky Way alone holds over 100 billion, including our Sun, the star we know best. Each star is a massive ball of hot gas, mostly hydrogen, and each one lives its own life cycle, from fiery birth to a dramatic end. Some stars are so small they barely glow. Others are so huge they would swallow Earth's entire orbit. And somewhere in the dark, a star so strange scientists still can't agree what it is, but that's another story. So, how does a star actually begin? It all starts in a cold, massive cloud. A single cloud can be millions of times the mass of our Sun. Inside it, gas begins to clump together. Gravity pulls these clumps tighter until a dense pocket collapses under its own weight. As it collapses, it heats up. This hot core is the birth of a new star. We call it a protostar. And that strange star from last episode? It's real. It's called Tabby's star. And no one knows why it dims so mysteriously. Why dimming is strange. A star truly lives when nuclear fusion begins. Hydrogen fuses into helium, pushing outward with enormous energy. Gravity pulls inward with equal strength. This perfect balance is the main sequence. Our Sun. It's midway through this long, steady life. But not all stars live the same way. Small stars burn slow and cool, lasting trillions of years. Massive stars burn hot and fast, dying in just millions. And Tabby's star? It dims irregularly because something keeps blocking its light. Dust, gas, or something we still can't explain. But eventually, every star faces the same fate. What really happens when a star dies? Every star, no matter how bright, eventually reaches its end. When a star runs out of hydrogen, its core begins to shrink. Gravity pulls inward, pressure pushes outward, and everything starts to change. Smaller stars, like our Sun, expand into giant swollen shells of gas. Their outer layers drift away into space, forming glowing clouds called planetary nebulae. What remains is a hot, Earth-sized ember, a white dwarf, slowly cooling for billions of years. But massive stars end differently. Their cores fuse heavier and heavier elements, until they reach iron, the final barrier no star can cross. Fusion stops, gravity wins, and in a fraction of a second, the core collapses. Then comes one of the universe's most powerful explosions. A supernova, bright enough to outshine a galaxy. What's left behind? Sometimes a neutron star, sometimes a black hole, and sometimes a star that dies in a way scientists still struggle to explain. But we answered why a star can dim mysteriously, but some stars do something far stranger. They die long before they should. A massive star is supposed to collapse only after burning through all its fuel. Hydrogen, helium, heavier elements. There's a sequence, a cosmic schedule. But one giant star broke the rules. A red supergiant in NGC 6946, known as N6946 was still burning, then suddenly vanished. No explosion, just gone. Scientists think it collapsed straight into a black hole, quietly, early, invisibly, as if its core hit a failure point our physics can't yet predict. If a star can die without running out of fuel, how many silent deaths are happening across the universe right now? And stranger still, some stars explode too early. That mystery comes next. Last time, we found stars that die quietly, fading into nothing. But some stars don't go quietly at all. They explode long before they're supposed to. In space, we expect massive stars to explode only after they run out of fuel, but a rare group breaks the rules. Meet SN 2006 GY, a star so huge it should have lived longer, yet it detonated early, in an explosion 10 times brighter than a normal supernova. Others, like SN 2014C, begin as one kind of explosion, then change mid-blast, as if the star shed layers we didn't know were missing. Astronomers have theories, maybe violent mass loss, maybe a hidden companion star, or physics inside the core we still don't understand. We only know this: some stars die faster than models predict, as if something deep inside them decides not to wait. But if a star can explode too early, what about the ones that refuse to stay dead? Because somewhere out there, a star exploded once, dimmed, and then came back. A supernova. That happened
Last
twice.
time we saw
That
stars
mystery that exploded too early. But some stars do something even stranger. They fade, almost disappear, and then return. Take our Corona Borealis, a star that suddenly drops 90% of its light for months or years. To us, it looks like it died, a silent collapse, gone. But what really happens? The star builds tiny clouds of carbon, like soot from a cosmic candle. These clouds drift across our view, covering the star completely, until it's nearly invisible. And then, when the carbon finally thins, the light returns. Other stars do even more dramatic tricks. Some swell, collapse, and ignite again, so-called born-again stars. Not explosions, not death, just stars changing in ways we still don't fully understand. But if a star can vanish without dying, in the next story, we meet the ones that die, without exploding. Some stars end with a roar, but others end with something far quieter. A silent fading, a life that doesn't explode, it simply stops. Most stars die in fire, blazing supernovae lighting whole galaxies, but a rare few slip away quietly. No explosion, no final flash. Meet SAO 244567, a star that shrank faster than any we've ever witnessed. It heated, collapsed, and simply faded, as if exhaling its last breath in silence. Others shed their layers gently, leaving behind ghostly shells we call planetary nebulae. A soft ending, a star choosing quiet instead of fire. And maybe that's the universe's reminder: not every ending is loud. Some are gentle and strangely beautiful. Star series moments remind us we too are part of this balance, born, growing, aging, fading, carrying mysteries of our own. In this journey, we watched stars the way the universe sees us, as brief sparks in an endless night. We learned how they are born from dust, how they shine, how they age. We saw the quiet dimming of Tabby's star and the strange collapses that defy every model. We met stars that die too early, others that fade and return, and some that end in silence. Every one of them, a reminder that the universe rarely follows the rules we write for it. And maybe that's why their stories feel familiar, because we too burn bright for a moment, change, fade, and begin again in ways we hardly understand. Thank you for being part of this first season of AY Universe Files. Stay close. The next mysteries are already unfolding.